Imagine a moment so fleeting, so incomprehensible that it birthed everything we know. Every star, every galaxy, every whisper of light that dances across the cosmos. The Big Bang, a cosmic explosion 13.8 billion years ago, is the cornerstone of our understanding of the universe's origin. It's the story of how an unimaginably hot, dense point expanded into the vast, sprawling universe we inhabit today. But what if this was not the beginning? What if the Big Bang was just a chapter in a grander, more mysterious tale? What came before? This question, one of the greatest enigmas in science, pulls us into a journey through the edges of physics, philosophy, and human curiosity. Buckle up, because we're diving into the deepest mysteries of existence, exploring the latest discoveries, and asking you to join us in pondering the unimaginable. Hit that like button if you're ready to explore the unknown, and let's get started. Picture a moment of infinite density, where all the matter, energy, space, and time of the universe were compressed into a single point. A singularity so extreme that our laws of physics can't even begin to describe it. Then, in a fraction of a second, it erupted. The Big Bang, occurring 13.8 billion years ago, wasn't an explosion into space, but an expansion of space itself. In that first heartbeat of existence, the universe ballooned faster than the speed of light in a process called cosmic inflation, stretching and cooling as it grew. Within a mere second, a searing soup of particles, quarks, electrons, and photons swirled in a chaotic dance. By 3 minutes, the universe had cooled enough for protons and neutrons to fuse, forming the first light elements, hydrogen and helium, the building blocks of stars. But here's the kicker. For the first 380,000 years, the universe was a cosmic fog, so hot and dense that light couldn't travel far. Photons were trapped, scattered by free electrons in a plasma too thick to let them roam. Then, a pivotal moment arrived, the epoch of recombination. As the universe expanded and cooled to about 3000 Kelvin, electrons began pairing with nuclei to form neutral atoms. Suddenly, light broke free, streaming across the cosmos in a burst of clarity. This ancient light, stretched over billions of years into the microwave spectrum, is what we now call the cosmic microwave background, CMB. It's a snapshot of the universe at its tender age of 380,000 years, a relic of its fiery infancy. The CMB is more than just a cosmic photograph. It's a treasure map. Discovered in 1965 by Arno Penzias and Robert Wilson, this faint glow, detectable from every direction in the sky, reveals tiny temperature fluctuations, seeds of the galaxies and clusters that would form billions of years later. These fluctuations, mapped with increasing precision by telescopes like the Atacama Cosmology Telescope ACT, show the universe's earliest structure, subtle hills and valleys in the density of matter that gravity would sculpt into the cosmic web we see today. In March 2025, researchers from ACT and Princeton University unveiled the most detailed CMB images yet, with 5 times the resolution of previous maps by the Planck satellite. These images, capturing the polarization of this ancient light, reveal not just where matter was, but how it moved, offering clues to the universe's earliest dynamics. Dr. Suzanne Staggs, ACT's director, described it as seeing the universe's first steps, frozen in time. Isn't that mind-blowing? Drop a comment below with your thoughts. After recombination, the universe entered a mysterious phase known as the Cosmic Dark Ages. The fog had lifted, but no new light had yet appeared. No stars, no galaxies, just a cooling, dimming void. For hundreds of millions of years, the universe was a quiet, starless expanse, its matter slowly gathering under gravity's pull. Then, around 100 to 200 million years after the Big Bang, the first stars ignited, massive, short-lived beacons known as population 3 stars. These cosmic pioneers, born in dense clouds of hydrogen and helium, blazed with ferocious intensity, flooding the universe with light and marking the cosmic dawn. Enter the James Webb Space Telescope, JWST, launched in 2021, a marvel of engineering designed to peer into this ancient era. JWST's infrared eyes can detect light from the universe's earliest galaxies, stretched into longer wavelengths by cosmic expansion. Since its first images in 2022, JWST has rewritten the record books, spotting galaxies that formed just a few 100 million years after the Big Bang. One standout discovery, announced in 2025, is the galaxy whimsically named MOMZ-14, the most distant ever observed. Its light, captured after a 13.5 billion year journey, shows MOMZ14 as it was just 280 million years after the Big Bang, when the universe was a mere 2% of its current age. This galaxy, bursting with rapid star formation and rich in nitrogen, hints at processes that challenge our models of early galaxy formation. How could such bright, massive galaxies form so quickly? Are our timelines off, or were these early stars more efficient than we thought? These questions are shaking the foundations of cosmology, and we want to hear your take. Share your theories in the comments. As the universe aged, gravity worked its magic, weaving matter into a vast cosmic web. Galaxies, born from those early density fluctuations in the CMB, didn't scatter randomly. They formed filaments, walls, and sheets, with vast voids stretching between them. This web, visible today through galaxy surveys, traces its origins back to those primordial seeds. Our standard model, the lambda cold dark matter, lambda CDM model, predicts that structures should grow to a certain size, about a billion light years across, before the universe's homogeneity takes over, ensuring no region looks drastically different from another. But the universe loves to surprise us. In 2024, astronomers discovered the Big Ring, a colossal structure spanning 1.3 billion light years in diameter and 4 billion light years in circumference, observed as it was 9.2 billion years ago. Nearby lies the giant arc, stretching an astonishing 3.3 billion light years. These cosmic leviathans dwarf our expectations, challenging the cosmological principle that the universe should look roughly the same on large scales. The Big Ring, upon closer inspection, may not be a ring at all, but a spiral or corkscrew twisting through space, a structure so vast it would appear 15 times wider than the full moon if we could see it with the naked eye. Alexia Lopez, the scientist who discovered these structures, remarked, "Their enormous sizes and unusual shapes are telling us something profound. But what? Could these be statistical flukes? Random clumps defying the odds? Or do they hint at new physics? Perhaps cosmic strings? Hypothetical defects in space-time from the early universe?" The debate is heating up, and we'd love to know, what do you think these megastructures could mean? Hit that comment section. The universe's story isn't just about what we can see, it's also about the invisible forces shaping it. Dark matter, making up about 27% of the cosmos, acts as the gravitational scaffolding for galaxies, while dark energy, roughly 68%, drives the universe's accelerating expansion. Discovered in 1998, this acceleration shocked scientists, who dubbed the mysterious force dark energy, possibly a cosmological constant tied to the vacuum of space. But recent data from the Dark Energy Spectroscopic Instrument, DSI, analyzing millions of galaxies and quasars, suggests dark energy might not be constant. In early 2025, DSI's 3-year survey revealed that dark energy's influence may be weakening, hinting at a universe where acceleration could slow or even reverse. Dr. Arjand of NSF's Noir Lab called it a dramatic shift in our cosmic picture. Could this mean a future where gravity regains control, leading to a cosmic collapse? The possibilities are thrilling. Share your predictions below. Meanwhile, dark matter remains elusive. Despite decades of searching, we've never directly detected its particles, prompting bold new ideas. In 2025, physicist Dr. Richard Lue proposed a radical model. What if the universe didn't start with one big bang, but multiple mini bangs? These transient singularities, brief bursts of matter and energy, could explain cosmic expansion and structure formation without dark matter or dark energy. Each burst, Leo suggests, floods the universe with mass and energy, triggering brief periods of accelerated expansion before fading. This model, while speculative, could account for the Big Ring and giant arc, suggesting they formed from these cosmic flickers. It's a wild idea, but it challenges us to rethink the universe's origin. What's your take on this MultiBang theory? Let's discuss! Now, let's tackle the big question. What came before the Big Bang? For decades, the standard answer was that time itself began with the Big Bang, making before a meaningless concept, like asking what's north of the North Pole. But modern theories push beyond this boundary. Sir Roger Penrose's conformal cyclic cosmology proposes that our universe is one in an infinite series of aeons. As our universe expands and decays into a near-empty state, it could reset into conditions resembling a new Big Bang. Penrose even even claims to have found circular patterns in the CMB, possible imprints of gravitational waves from a previous universe, though most scientists remain skeptical. Another idea, loop quantum cosmology, suggests the Big Bang was a big bounce, a collapsing universe rebounding into ours. In this model, time stretches back through the bounce, implying a pre-Big Bang cosmos. If Desi's hints of evolving dark energy hold true, we might imagine our universe one day contracting, setting the stage for another bounce. These cyclic and bouncing models offer tantalizing answers to what came before. Another universe, another cycle, another story. Which idea resonates with you? Drop a comment and let's explore together. Let's venture deeper into the quantum realm, where the rules of reality bend and twist in ways that defy intuition. The question of what came before the Big Bang isn't just a matter of telescopes and starlight, it's a challenge for quantum physics, where the very nature of time and space comes into question. Loop quantum cosmology, mentioned earlier, isn't the only theory pushing the boundaries. Other quantum gravity models, like string theory, propose that our universe might be one of many in a vast multiverse, where different regions of space-time bubble up with their own physical laws. In this view, our Big Bang could have been a local event, a spark in a larger cosmic foam where universes are born and die endlessly. Imagine that, our entire cosmos with its 13.8 billion years of history might be just one bubble in an infinite sea. Does the idea of a multiverse spark your imagination, or does it feel too far-fetched? Share your thoughts in the comments, and let's dive into this cosmic rabbit hole together. Even if we can't see before the Big Bang, could there be echoes of that pre-cosmic era hidden in our universe? Scientists are hunting for these clues in the CMB's subtle patterns and the distribution of galaxies. For instance, some physicists speculate that primordial gravitational waves, ripples in space-time from the universe's earliest moments, might leave faint imprints in the CMB's polarization. In 2025, the Simons Observatory, a next-generation CMB experiment, began operations in Chile's Atacama Desert, aiming to detect these elusive signals with unprecedented sensitivity. If found, they could confirm theories like cosmic inflation or even hint at events before the Big Bang, such as the collapse of a previous universe. Meanwhile, galaxy surveys like those from the Euclid Space Telescope, launched in 2023, are mapping the cosmic web in 3D, revealing how structures evolved from those early CMB seeds. These missions are like cosmic detectives, piecing together clues from the universe's infancy. What kind of evidence would convince you of a pre-Big Bang reality? Let us know below. Why does the question of what came before grip us so tightly? It's not just about science, it's about who we are. Humans have always looked to the stars for answers, from ancient myths of creation to modern equations probing the singularity. This quest reflects our need to understand our place in the grand tapestry of existence. Are we the product of a singular moment, or part of an eternal cycle? The search for what came before the Big Bang bridges physics and philosophy, challenging us to confront the limits of knowledge and the power of imagination. As we build better telescopes, refine our theories, and analyze data from projects like DESI and the Simons Observatory, we're not just chasing facts, we're chasing meaning. This journey, fueled by curiosity, unites us all. So what drives you to ponder the cosmos? Share your cosmic musings in the comments, and let's keep unraveling the mystery together. Let's take a moment to explore one of the most tantalizing ideas in cosmology, cosmic strings. These hypothetical, ultra-thin defects in the fabric of space-time are theorized to have formed during the universe's earliest moments, when the cosmos underwent phase transitions akin to water freezing into ice. Unlike anything we encounter in everyday life, cosmic strings are infinitesimally narrow, but incredibly dense, stretching across vast cosmic distances and carrying immense energy. If they exist, they could have played a pivotal role in shaping the universe's structure, potentially seeding the formation of galaxies, or even the massive structures like the Big Ring and Giant Arc. In 2025, researchers using data from the Square Kilometer Array's precursor telescopes reported tentative hints of gravitational lensing patterns that might align with the presence of cosmic strings. While far from confirmed, these findings ignite the imagination. Could these invisible threads hold clues to a pre-Big Bang era, perhaps as relics of a previous cosmic cycle? The idea is as thrilling as it is speculative. Drop a comment with your thoughts on whether cosmic strings could rewrite our cosmic history. As we ponder what came before, we can't help but wonder what lies ahead. The discovery of dark energy's potential evolution, hinted at by Desai's 2025 findings, opens up dramatic possibilities for the universe's future. If dark energy is weakening, the relentless acceleration driving galaxies apart could slow, allowing gravity to take the reins once more. Picture a universe where expansion halts, and over eons, galaxies begin to converge, drawn together by their mutual gravitational pull. Some models even suggest a big crunch, where the cosmos collapses back into a dense state, potentially sparking a new Big Bang. This cyclical vision aligns with ideas like Penrose's conformal cyclic cosmology or the Big Bounce, suggesting our universe might be part of an eternal dance of expansion and collapse. The thought is both humbling and exhilarating. Could our cosmic story be just one stanza in an infinite poem? What do you think the universe's fate might be? Share your predictions in the comments and let's speculate together. At the heart of our quest to understand the Big Bang and what came before lies a deeper ambition, a unified theory of quantum gravity, often called the theory of everything. Such a theory would merge Einstein's general relativity, which governs the large-scale structure of space-time, with quantum mechanics, which rules the subatomic world. Current models like string theory and loop quantum cosmology offer glimpses of this unification, suggesting that the Big Bang's singularity might not be an impenetrable barrier, but a gateway to understanding the pre-bang cosmos. In 2025, advancements in quantum computing allowed researchers to simulate complex quantum gravity scenarios, revealing possible pathways for how space-time could transition through a bounce or emerge from a multiverse. While we're still far from a complete theory, these efforts highlight humanity's relentless drive to decode the universe's deepest secrets. Imagine a future where we unlock the equations governing existence itself. What questions would you ask such a theory? Hit that like button if you're excited about this cosmic puzzle, and share your ideas below. Now, let's tune into the universe as if it were a grand symphony, its notes played out across billions of years. Every galaxy, every star, every ripple in space-time is part of a cosmic melody that began with the Big Bang, or perhaps even before. Theories like the ekpyrotic universe model propose that our cosmos emerged from the collision of higher dimensional branes, vast membranes floating in a multidimensional space. This collision, rather than a singular explosion, could have sparked the expansion we observe, with the pre-bang universe existing as another brane, vibrating in harmony or discord with our own. In 2025, researchers at CERN's Large Hadron Collider explored high-energy particle collisions to test string theory's predictions, seeking evidence of extra dimensions that might support such models. While no definitive signs have emerged, the possibility that our universe is part of a larger, multidimensional orchestra captivates the imagination. Picture the Big Bang as a single chord in an eternal composition, with echoes of previous notes lingering in the CMB or the cosmic web structure. Does this idea of a cosmic symphony resonate with you? Drop a comment and tell us how you envision the universe's music. What if our universe is just one stroke on an infinite canvas, painted alongside countless others? The multiverse hypothesis stretches our minds to consider a reality where every possible universe exists, each with its own laws of physics, constants, and histories. In this framework, the Big Bang was not a unique event, but one of many, each universe bubbling up from a quantum foam or emerging from a cosmic collision. Recent theoretical work in 2025, building on inflationary cosmology, suggests that inflation itself could spawn multiple universes, each inflating at different rates or with different properties. These pocket universes might never interact with ours, yet their existence could explain why our universe's constants, like the strength of gravity or the mass of an electron, are so finely tuned for life. The multiverse challenges us to rethink the uniqueness of our cosmic story, inviting us to wonder if we're part of a single masterpiece or a gallery of infinite artworks. What's your take on the multiverse? Does it feel like a cosmic truth or a leap too far? Share your thoughts in the comments, hit that like button if this idea sparks your curiosity, and let's keep painting the picture of the cosmos together. The Big Bang Theory has carried us far, painting a vivid picture of a universe born in fire, sculpted by gravity, and driven apart by dark forces. Yet every discovery, from the CMB's detailed maps to JWST's ancient galaxies and DESI's evolving dark energy, reveals new questions. The Big Ring and Giant Arc challenge our assumptions about cosmic structure, while theories like Lu's mini-bangs and Penrose's cyclic cosmos push us to imagine beyond a singular beginning. We may never directly see what came came before the Big Bang, but the clues are mounting. Future telescopes like the Simons Observatory could reveal subtle patterns in the CMB or galaxy distributions, hinting at a pre-Big Bang reality. As we stand at the frontier of scientific understanding, the question of what came before remains a beacon for curiosity. It's a reminder that the universe is not just a place, but a story, one we're all part of. So what do you think? Was the Big Bang the ultimate beginning, a bounce, or one of many bursts? Subscribe to join the cosmic journey, like this video if it sparked your imagination, and share your thoughts in the comments. Let's keep exploring the mysteries of the cosmos together.